Just to make sure I'm not insane, I'm doing it on camera. And now it works! You mother... not family friendly expressions. 10 of them at least. 1, 2, 3, 4, 5. Crap. Now it works. I swear I twisted it as further as I could. Now it's working. What? This is not a phone charger and this is not a laptop charger, because if you look closer, it's a power adapter and it gives output 5 volts 1 amp. So that is definitely not a charger. It doesn't interrupt the voltage in any time. It just keeps giving 5 volts constantly until you unplug it from the wall. So yeah, this is a power supply. That's the standard definition. Same goes for this. This is for a laptop. Yeah, the output is 19 volts, 2 amps, and that's it. It doesn't switch off, it doesn't increase the voltage, decrease the voltage, depending on the state of charge of the battery. It just stays at 19 volts until you unplug it from the wall. So, yeah, this is a power supply, AC-DC adapter. That's also a way to say it. Yeah, there are several definitions, but definitely not a charger. So, a charger does something like this. For one lithium-ion battery cell, it should start charging at around 3 volts and slowly go up to 4.2 or 4.4 in some cases with the higher capacity cells, but in general 4.2. And then when it's charged, when the charger determines that the battery cell is charged, it stops, and you can measure the voltage being 0 on the charger when it determines that the cell was charged. Yeah, and in general it takes 2 hours, but that doesn't really matter. It depends. Some chargers do it in less than that, depending on the manufacturer, or if you can configure it yourself, then it depends on your configuration. So yeah, but what my point with this is that I want to make a really powerful phone charger, yeah, power supply for a phone. So this is the DC to DC step down voltage regulator, which can support up to 3 amp output, which means that it basically does the same thing as this. This is a car charger or a phone charger meant for use in cars, which can take 24 volts or 12 volts and step it down to 5 volts to supply up to 3 amps. No, I think 2.4. This one was rated for 2.4 and burned down. 2.4 amps on 5 volts, yeah. So if you have a look at the components, this tiny little thing with 2 teeny tiny little capacitors and this tiny little coil, and then look at these capacitors, huge, and the better kind that doesn't spill, and look at the coil. Teeny tiny coil, large coil, and the controller chip is also more professional in this one. And yeah, this doesn't really matter. You could replace this with a fixed value, but this is adjustable. You can adjust the output voltage. So yeah, I'm going to replace this burn down thing with this thing, much more professional. And ironically, this costs the same. This piece of shit car charger was slightly more than $2, and this is exactly the same, like $2.4, $2.3, whatever. 10 Romanian leis, okay? Both were the same. 10 leis or 10 RONs. So what I want to do is just break off these USB ports from here and connect them to the output and connect a 12-volt supply to this. And then we'll try to charge a power bank. I don't want to charge my phone because if I do something stupid, then I don't want to burn it down. But this stupid power bank cost me like $8, so I don't care. It's a 10 amp hour unit. So yeah, let's get some wires, connect them to the power supply. This is a 12-volt, very bad power supply that barely gives out half an amp. But it's good for testing and setting the voltage, the output voltage on the step down voltage regulator. So here is some wire, and professionally connect this to the plug because I don't have a barrel plug right now. I have to improvise. So I put a screw in the middle. I connect the positive to that. Yes. Don't do this at home because you may burn down the charger. I mean power supply, whatever you call it. People still call them chargers. The negative will go here. Maybe I'll disconnect it from the outlet just to make sure I don't burn anything. So yeah, this is how I usually improvise a connection, or just have a zip tie like here. That's good enough. Yeah, push this in a little more, and let's connect the output to the voltage regulator. Man, my nails can't handle this. Let's try some scissors. Come on, man. Okay. Whatever. Some solder on. Okay. So this is the input. Connected to the other side. Maybe. It doesn't really matter, but I don't know why. I want to connect it to the back side. Some more solder. Wait. And nice connection. Yeah, this is the input. Just double check. Don't assume anything. Because you know what they say about assuming. It's not family friendly, so I'm not going to say it here, but yeah, that's what they say. So let's break off this port. As you can see, it usually has an arrow pointing to the top port that it will support 2 amps and the lower port only 1 amp. That's BS because they are usually connected. You see? They connected the data wires in one, and the positive and negative are also connected. So there's no way to differentiate between those two electrically. They both get the same power. So, yeah. So, let's cut it like a barbarian. Oh, yeah. I forgot this is really brittle. It just broke. It didn't wait for me to cut it professionally. So, let's just cut it straight. Man, this is not a proper circuit board. I don't know if you can see it, but this is as brittle as a piece of plastic or something. Plastic would be stronger, I think. Okay. So this will actually output 3 amps total through this DC to DC board. And yeah, I just need a strong power supply for that. For 3 amps with 93% efficiency, I need a 12 volt power supply with at least 1.8 or something amp output. Or 2 amp output, yeah. That's the... And then this little thing can output 3 amps, hopefully without heating up, because this piece of shit heated up. This coil heated up so much that it actually, you can see a burn mark on the chip. Some soot or something, some dust or particles landed on the chip from the coil. So yeah, this was not very well designed. Maybe for half an amp. It could handle half an amp charging one old smartphone, not smartphone, feature phone. With half an amp it could charge it. But when I put on my smartphone, connected my smartphone, and I tried to charge at, that charges at 2 amps. At 2 amps it burned down. Yeah. Lasted like a minute or 2 minutes, and pff, it was over. So yeah, maybe the chip is still okay, and the capacitors, but yeah, I don't really care. I care much more about this useful USB port. So let's connect it. I'm not going to use very thick wires now. It's just for testing. I use the same wires, but in theory you shouldn't use these for 3 amps. These are maybe good for 1 or maximum 2 amps in my experience. Otherwise it starts overheating or stops supplying the device. I don't know how that happens exactly. I'm not an electrician, but yeah, it happened to me. I tried to connect an electric drill through this, like 12 volts. I tried to supply 12 volts with these thin wires, and yeah, it could turn the drill. It turned it, yes, it was spinning, but under higher load it just stopped. So yeah, not recommended. This is Cat5 network cable. So let's strip it. Where's my stripping tool, aka scissors? My other tool is not very good at its job, which was actually designed to strip wires. It's not working very well, but hey, let's do it old school. Spin it, and then it comes off easy. Yeah. So if it's not connected, I can supply 20 volts to this. It doesn't matter. Just don't plug anything in until you adjust the voltage from the spinny thing. Hey, I dropped the wire and also the solder. That is so funny. The solder blob fell down. That used to happen to me when I was a kid and started soldering. Some more solder. Perfect. And not perfect. Clean the tip. Fresh solder and try again. Okay. So one will go to the I don't know which one is the positive and which one's the negative. Can we guess? Let's look at the charger. I had one laying around somewhere. I have two, but they are connected. So let's look at this crappy one. Oh, we don't have to look. I'm stupid. This is the ground. So that's the negative. Yeah, I'm being stupid. This is the negative and this is the positive. So yeah. Because they are poorly designed from the start. You can notice. Yes, the positive doesn't touch anything. Hopefully it didn't melt anything. And the negative can go anywhere almost on this whole thing. But I'll connect it where you're supposed to. Okay, negative connected. And let's connect these to the output and let's check for shorts, because you never know what you did wrong until you burn something or check. So positive. Yes, and negative. Yes? Am I right? So now, let's see the multimeter. Here, turn it on. It says 666, not the devil. That just means low battery. Every time I turn it on, it says 666. Whatever. 20 volts. Let's hope it's not set higher. And let's turn it on. Or let's not. Let's check for shorts. Let's check for shorts. Yep, that is okay. And this is also okay. I think. A short would sound like this. So, let's connect it and measure voltage here on the output. Oh, I have to turn it around because I'll have to twist the... like that. I will have to twist the knob. Let me get the screwdriver for that. Slightly bigger tip. Oh, crap. I just broke something. Whatever. Here it is. A nice clean screwdriver. And I will have to twist that. And measure the voltage on the out. Let me get in position here. Oh, like that. and the negative. Wait, oh, is that the positive? So like that, I will just lay on the desk, plug in the... Oh, it lights up. And it's set to 0. I mean, it barely reduces the voltage. 11.5. Wait, what? Wait a second. Is this the proper module? Because I have this also on my... This is funny, because I set this one to exactly 11.5 volts. I haven't touched this yet. So it comes with 11.5 set. That's a coincidence. Funny. Yeah. Interesting. So out. And let's turn it down to 5. Wait. What am I doing wrong? The other direction. This is strange. I'm turning it and it's not decreasing the voltage. What's happening here? What I'm doing wrong? This is not good. What? The voltage is constant. But why? So the input is 12.2 and the output is 11.5, and it even increased a little when I'm trying to decrease it. What? Something is not working here. I got a defective. Light is turned on. It means it's okay. It should be working. Nothing is heating up. What? So, yeah, that's the positive. So keep turning it. I don't know what else to do. But this doesn't do anything. Man, I have to read something. A manual or something. So this probably arrived dead. because I can't move the voltage anywhere. If I plug it in, I connected my multimeter directly to the output, so it's only the multimeter set at 20 volts. And let me just plug it in. Yes, it's exactly 11.5 volts. So what can I do? Twist it this way. Just to make sure I'm not insane, I'm doing it on camera. And now it works! You mother... not family friendly expressions. 10 of them at least. 1, 2, 3, 4, 5. Crap. Now it works. I swear I twisted it as further as I could. Now it's working. What? Okay, I want to adjust it exactly to 5. But it doesn't really matter because phone power supplies, I mean chargers, whatever you want to call them, they can output anywhere between 4.8 to 5.3 as a starting voltage. Then when you put load on it, it may drop a bit. But yeah, 5.2 is fine. Okay. False alarm. I thought I will have to return this crap. So yeah. Let me take it out of the... Yeah, disconnected it. Solder back the USB port and try it out. If I can. So this is the negative. I don't care how it looks. Or maybe I do. Let's straighten that out. Oh boy, this is making me look like a fool. This piece of... Actually not garbage. If it works. Yeah. So let's just connect it. Yeah, it's good enough. And this is the positive, which will go to the positive side. Oh boy. Oh boy, oh boy, oh boy. So yeah. Let's try it out one more time. The multimeter just keeps turning off. Maybe it does have a low battery. And it's on. Measure the voltage. 502. Okay, my mistake. I'm sorry. So let's connect the power bank to this. Yeah, it's in. Okay. And let's see if it charges and how much the voltage drops. Because this wants to charge at 2 amps. Which should... It should handle it. I don't know. It's not charging. Maybe it's a connection problem. The positive is the positive and the negative is the negative. What's the problem here? I plugged it in. Oh, now it charges. It's a problem with the cable. Look, it's charging. Here are the... Does it show up? Yeah, this is a crappy cable. Now it's charging. If it's blinking, then it's at 50% and tries to charge to 75. Okay, try not to move anything and measure the voltage. Let's see how much it drops. Yeah, 4.66 under load. Now that could be a problem with the step down circuit, but it also can mean that the input dropped. Wait, let's see. The input also dropped. Oh boy, that's the problem. This crappy power supply dropped to 5 volts. Oh boy. That's just stupid. I mean, this end was down to 5 volts. Okay. So yeah, that's why the voltage dropped. That's a good explanation. I'll have to connect a stronger power supply. So as you can see, it's 5.01. That's good. When it's not under load. When I put load on it, then this crappy power supply gives out. Let me show you what's inside. You'd think it's a big, strong power supply with 2 amp output. Look, it says 12 volts, 2 amps. Yeah, America. Actually, China. But inside there's this dinky little thing. The whole thing is empty, and this can barely charge a phone. Yeah. They use this for this exact circuit board with the exact same components. They sell this as a phone charger that can output 500 to 700 milliamps on 5 volts. So yeah, I mean, they changed the voltage slightly with one of these components here. So the regulator chip that outputs 5 volts, but the power is the same and it's shit. So yeah, I will have to connect it to a stronger power supply. Should I connect it now? Yeah, let's try it now. Here's a real power supply that is really heavy, and it really outputs 3 amps on 12 volts. I tried this and it works very well. So let me just do that stupid connection. I hope nobody watches this. I will just switch over the screw and the if I can. Oh, this one doesn't go as deep, but it will be fine. Like that. It just has to stay. Okay, and let's connect the power bank also. And let's see the voltages. Let me get this out of the way, this crappy power supply. I'm not feeling like replacing the USB cable. That would remain the shitty one. So let's see. I'm not plugging it in yet. First I want to see if all the wires are connected properly. Let me show you a multimeter or something in a corner somewhere. Let's move everything over here. Oh, it fell out. Perfect. Focus. Oh, come on. Space management. This should stay here so you can see the LEDs. Let me connect the power supplies, plug the amateur way. And yeah, now everything is connected, but you can't see. Oh boy. Yeah, now everything is connected. Yeah, the battery bone is connected to the USB bone. The USB bone is connected to the DC to DC step down voltage regulator. And the regulator is connected to the strong power supply. Okay, and then let's connect the power supply to the wall outlet. And let's watch it spark. It's on and it's charging. Okay, now let's measure the voltage. So this should be taking 2 amps, the battery bank. Let's see the output of the power supply. 12 volts, yeah, that's strong because it can output 3 amps. And let's see the USB power. How can I? 5 volts. That's what I mean. Yeah, now it's working properly. Okay, no more cheap Chinese crap for me. This power supply always messes up my plans. That's really aggravating. So the solution works. It can output 2 amps at least, because this power bank right now is taking 2 amps. And I just have to connect it to a powerful power adapter. AC to DC power adapter, power supply, power brick, whatever you want to call it. Just don't call it a charger. Because the charger is inside the phone or laptop, and the battery also has a protection circuit inside, separate from the charger. And that protection circuit monitors the temperature, I think, and the internal resistance of the cell, hopefully, if it's advanced enough. Some Chinese solutions may just bypass all that and say it's all good, and then your phone will explode at some point. But in theory, the protection circuit has to monitor the cells and switch them off if there's a problem. And the charger is inside the phone or the laptop, and it manages the battery. Yeah, because you know, when you connect your phone, when the phone is connected to the USB power supply, then it runs on that power. It doesn't run on the battery. So the power supply is always on, and the phone or laptop is running on that power. And only when you unplug it, it will switch to the battery. Yeah. And the other one goes without saying, when it's connected, it also charges the battery. Yeah. Okay, so my bad. I didn't do it properly. I have no idea how to twist these blue things. It turns out that I was spinning it in the wrong direction. Lesson learned. And yeah, $2 solution, it's working properly, and I have to test it long term, but hopefully it won't burn down like this piece of crap. That's it for today.